All right, so now you've loaded your data, you've cleaned it up a little, and there's still a little more to do. We said we did some data wrangling, which was sort of cleaning up our data. And now what we need to do is something called feature engineering, which is that we want to take our data and make sure that we have the features we need to help predict our target. In this case, remember, our target is whether or not school is closed. And so we gotta ask ourselves, what are the features? What are the things we think will help be predictive of that? So we know that schools close mostly when there's a lot of snow. So the accumulation of snow might be important, accumulation of precipitation. You know, sometimes it's closed when there's a hurricane. So maybe wind speed is important. Amount of precipitation has something to do with sort of how long it sticks around, has something to do with temperature. So maybe we want to know about temperatures. So all those things that we sort of had seen before were good features. The point is, though, sometimes though you want features more than just the things that you measure. You might want to come up with new features that you think are somehow better predictive. And so what we're going to do now is we're going to sort of look about how we might create new features. So new features are basically going to be new columns in our table that we think are going to be useful. And so what we're going to do here is we're going to just sort of play around. So we're going to add a new column that we're going to call mid, which is equal to the average of the day's high and low temperature. Because remember, we had the high and low before. So maybe if we turn that just in the one column, that would be useful. And so we have our process table. So again, if you've reloaded your workbook, so your notebook from last time, you will have to run those cells above to make sure that you've loaded everything into them. Otherwise, when you run this, it's going to yell at you. So you run those cells to get everything catch back up. And then here we have this process table data frame that we created above. And we're going to create a new column. So there isn't a column called mid already. So by doing this, what we're doing is creating a new column. And it's going to be equal to the process table's min column plus the process table's max column divided by 2, which of course is the definition of the average. And so we do that. And then we can see we created this new column, which was the average of these two. Okay, if you want to make new columns based on some conditional statements, not equations, there are actually a number of ways to do this. But a straightforward method is like this. So here we're going to create a new column where all the cells contain the same value. So first I'm going to go ahead and just create a new column called freezing. And I'm going to have it be 0. That's in that binary sense that freezing 0 is going to probably be no. But let's just see what that does. This is just going to create a new column where everything's it's a column full of zeros. We want those to actually mean something though. So now what we're going to do is we're going to use some conditional statements. We're going to say basically, take the process table where the minimum, for those rows where the minimum value is less than 32 degrees, because our temperature is less than Fahrenheit, we're going to take the column freezing and set it equal to 1. So remind you of above when we took the closed and set them equal to 1. So if we do it that way, now we've replaced these freezing so that now if the minimum temperature actually drops below freezing, there will be a 1 in this column here. You can string logic together. So I could have done something where I could create a new column called cloudy and windy. Again, I'm going to start them off by default, all is equal to 0. And then based upon some logic, if the wind column is greater than 5 and the minimum temperature is less than 32, then I'm going to call it cold and windy. I guess like cloudy and windy a second ago. I'm a little tired about that. Sorry. And then I can set that equal to 1. And so what this will do is create a new column called cold and windy. And if it's cold and windy, it would make that column be 1. Dates, you can do some fun stuff with that. A full description of dealing with dates is really beyond the scope of this lesson, but you can learn more about date times here at this link. I'm going to import a library on date times, and what I'm going to do is look at process table. I'm going to call it days past. It's going to be today minus this here, and this is going to do is it just makes a new column with a number of days between today and the date column. So this is going to tell me just sort of how long ago it is. This I don't think is really useful for predicting whether or not school is closed. I'm just showing you that you can do stuff with dates. So in this case, this is days past since that first date. We can see what the days passed there. And again, just to give you an idea, nothing for you much to get very detailed, but you can do functions here too, right? And then you could use functions to do stuff. So here's a yesterday's high function. So as with JavaScript, you define a function. Here you do it, instead of saying function in the name, you say def and the name. And again, you have a parenthetical and the things that you're going to pass to it as parameters. These do act the same way as in JavaScript, which is to say that now you're creating a variable called row that you've passed to this function. And what this is going to do is, I'm not going to go into detail much here. If you want to look at it, you can look at the notebook. I'll just give you an idea that you can create functions. You can call those functions. You can use them to do your feature creation. It's going to say yesterday. And so it's just going to figure out what yesterday was based upon the date. So it's yesterday for the date in that column. And then it's going to say, oh, well, you can also have access to the process table. And then actually, if yesterday is greater than the min date, set yesterday's max to that of the previous day. And so basically what this is going to go through here is this just gives you an idea that you can use a function. You can return, just like in the JavaScript function, you can return out yesterday's max. You can turn out yesterday's maximum temperature, which is what this is doing. And that becomes useful because then you can use that, as we did above. You can pass this yesterday's high thing using this apply feature. And it's actually going to go ahead and then you can get yesterday's high. Hold on, I'm going to get an error here. Oh, I didn't actually run this cell. I have to run the cell to define it. And then if I run it, then it's going to think about it. And then I get this, and I've created now here a new column with yesterday's high. So I can see here, this was the second. I look back on the first, the high was 70.8. And here it is. You can see actually with the floating point, this is probably hiding a little bit of the actual number. And so that might be something that's useful because that gives you some idea about, like, is today a lot colder than yesterday or whatnot. We've played around with this a lot and made a lot of columns. We probably don't want all those columns. So we can make it just this. This is our subset from above. Remember, we can just take it and we can just change the data frame so it only has the things that we think are really important. And then here now we just have sort of accumulation, min, max, when, and yesterday's high. Those seem like things that might be useful. We want to make sure everything's really a number because we are going to feed this into some algorithms that are going to look to do that sort of plotting and finding of surfaces that we talked about 2 levels ago. So we can use this, again, we can look and see at the data types. And you see float, float, float. These guys are objects though. The reason those are objects is because look, some of these are blank, so they're probably strings. And so actually we can do a thing where we can try to coerce them in the same way that we coerced the dates above. We can try to do that. So here we're going to go to numeric. We're going to use arrows coerce, but then we're going to do something which is we're going to spit out how many rows there are, and then we're going to use this thing called drop in A, which is going to drop anything that's not a number. And then we'll see how many we drop because we'll see the length again. So what that shows us is we run it through. There are 951 rows, but after we get rid of all the ones that don't have numbers, there are 700, and that's probably those where we couldn't find a yesterday's high. That's probably a lot of what's going on there, but now we see that everything is a number, so we're good. If we didn't want to drop these ones, because we are losing rows, if we had a good way to know what we should be replacing those not numbers with, we could actually use fill NA, which is another method there, which would allow us to fill them with something. So fill them with like a value like 1 or 0 or an average of some other set of things. But you have to think really carefully if you're making up data to go in there, if it's actually valid to put something in. But now that we have all that data in this nice table, we've taken 2 tables, we combined them together, we've added a feature. Let's go ahead and let's save our work, and we actually can use this here you can say process table to CSV, which looks very much like a read from CSV, but it's going to CSV. We're actually going to create this file on our server there. This index label false is just to make sure that we don't save the row count in the first column. And so we'll save that. And now if you went back and you looked at your directory in Python Anywhere, you'd see that new file there. And that new file is something we're going to pick up and work with next time around. But now that's saved. And we'll talk about our mission down below, and that'll get us ready for class on Monday. All right, cheers.